Hello everyone, I am Dr. Chong Siat Ling from Faculty of Electrical and Electronic Engineering, UST Tun Hussein on Malaysia. In this video, I will share with you a topic on Laplace transform. The learning outcome of this video is you will learn to convert step functions to a unit step function. Why do we need to change from step functions to a unit step function? This is because finding the Laplace transform of step function by using the definition of Laplace transform is time-consuming. So, to solve this problem, the step function can be changed to a unit step function. Here is the working step with two values. Let's say gt equal to g1 for t more than equal to 0 or less than a, and g2 for t more than or equal to a. So the unit step function is g1 plus g2 minus g1 multiplied with hash t minus a. Similarly, for a step function with three values, we can obtain g1 for t more than or equal to 0 and less than a, and g2 for t more than or equal to a and less than b, and g3 for t more than or equal to b, where the unit step function we can define as g1 plus g2 minus g1 multiplied with hash t minus a plus g3 minus g2 multiplied with hash t minus b. Now, let's look at the example. Express the following step function as unit step function. Let's say fx is 1 minus 2t for t more than or equal to 0 as less than 2, and you get 0 for t more than or equal to 2. So, to find the unit step function, you have to follow this formula. g1 plus g2 minus g1 multiplied with hash t minus a. So in this question, g1 is referred to this one. So we have the 1 minus 2t as shown in the highlighted in the orange color. Then plus with g2 minus g1. So g2 value is 0 minus with 1 minus 2t, which is highlighted in the gray color, and multiply with hash t minus a. The a in this case is 2, so hash t minus 2. And then we simplify it. 1 minus 2t plus 2t minus 1 multiplied with hash t minus 2. Okay, so we simplify and we get 1 minus 2t plus 2 t minus 2 plus 3 hash t minus 2. Since we have the hash t minus 2 here, t minus 2, so we also, the t is substitute with t minus 2. But original value is t minus 1. So we have to factorize it. We substitute first t minus 2. But let's say if you multiply in, you get 2t minus 4. This is not the original value. The original value is 2t minus 1. So you have to plus 3 to get the value of negative 1. Question B is to solve a step function with three values. You can use the formula on your right as a guideline to solve the unit step functions. Now, let's look at it. gt equal to g1. g1 is 3 plus g2 minus g1. g2 is t squared minus g1 is 3 multiply with hash t minus a. A in this case is 5 plus g3 minus g2. g3 is exponent power of negative 2t minus with t squared multiply with hash t minus b. Okay, this will equivalent to, okay, now hash
t minus 5. So for the t in front, you must also substitute t with t minus 5. Okay, substitute t with t minus 5. And then for the second expression, you must substitute with t minus 8. Okay, for the t here. Okay, now 3 plus the t is substitute with t minus 5. Okay, but original is t squared minus 3. So now it's t minus 5. This t minus 5 is follow the expression of hash t minus 5, but do not same as the original value. So we must plus 5 to return it to the original value. So this is t squared minus 3. Okay. Now let's check. For this t minus 5 plus 5, you will obtain t. So with the square, you got t squared minus 3. So it's the same with the original value. Okay, so multiply with hash t minus 5. For the second expression, exponent power of negative 2t. The t here also substitute with t minus 8, which is follow the expression of hash t minus 8. But if you look at here, when you multiply in, you get exponent power of negative 2t plus 16. This 16 is an extra. It's not same as original, so we want to minus the 16 to get back the negative 2t only. Okay, minus with t squared. So again, t squared, the t need to substitute with t minus 8. So t minus 8, the 8 is a negative 8 is an extra, so we need to plus 8. So t minus 8 plus 8 is still equal to t. So this is referred to the t squared. Then multiply with hash t minus 8. Okay, do you get it now? Question C also 3 values of step function. You can use the formula on your right as a guideline in solving the unit step function. Now, let's look at it. Gt equal to G1. So this is your G1 equal to 2 plus G2 minus G1. G2 is T minus G1 is 2. Multiply with hash T minus A. A is 3 plus G3. G3 is 1 minus with G2. G2 is T. Then multiply with hash T minus B. B is 5. Okay, so this is the expression for the unit step function. Now, let's plot it. Okay, we draw a x-axis and y-axis. So, x-axis we have 1, 2, 3, 4, 5, 6. So, y-axis we do have 1, 2, 3, 4, 5, 6. Okay, now let's look at it. From 0 to 3, you have the value of 2. This means that, okay, I use a different color. Okay, from 0 to 3. Okay, from 0 to 3, you have the value of 2. Okay, this is 2. Then from 3 to 5, you have the value of t. Let's say you don't know what is the value of t, you can substitute when t equal to 3, so y also equal to 3. When t equal to 4, y also equal to 4. We use the formula of t. So now in this graph is plot from 3 to 5. So t equal to 5, y also equal to 5. We can plot here. 3 is 3, 4 is 4, then 5 is 5. Okay, there's a straight line here. And then so the t is depends on the value of t, which range we want to plot. Okay, next is t more than 5. So starting from 5, so the value is 1. So 1, so when t more than or equal to 5, so this means that the t is t-axis or the x-axis is equal to starting from 5. The amplitude is 1. So it's like this. So we can connect the line. So we get the graph of unit step function like this. Okay, do you get it now?
Thank you for your attention. See you again on next class.